this lesson, we're going to be talking about how to solve quadratic equations by taking square roots. Now, in problems where you just have an x squared and there is no x to the first degree, we can solve for x squared. So isolate the x squared term. So we'll bring 16 to the other side. So you have x squared equals 16. And then the opposite of squaring something is taking the square root. And so if you take the square root of this side, we also have to take the square root of the other side. And so x then is equal to the square root of 16, which actually, when we're doing a problem like this, we need to think about what values work for x. Well, 4 times 4 gives us 16. And also, negative 4 times negative 4 gives us 16. And so there's a positive and a negative value of x that will work. So when we're solving equations and we take the square root, we have to say that x could equal either plus or minus the square root of 16, which is plus or minus 4. In the next problem, again, we'll get x squared by itself. So we have x squared equals 36. Take the square root of both sides. So basically this cancels this. So we have x is equal to plus or minus 6. In the next problem, x squared is here, and there's a lot of stuff going on. So the first thing we're going to do is add 50 to both sides to isolate the variable term. So that is x squared equals 50. And we want to now isolate x squared, and right now x squared is getting multiplied by 2, so we will divide both sides by 2. So x squared equals 25. And now we can take the square root of both sides. So x is equal to plus or minus 5. All right, and we'll just maybe do a couple more here. So first of all, we'll subtract 10 from both sides. So we'd have 4x squared equals 36. Divide both sides by 4. X squared equals 9. And then we'll take the square root of both sides. So x then equals plus or minus 3. And let's move into this next type of problem. Now here, notice on the left, we have a perfect square trinomial, which could be factored into two binomials. So we could write x plus 2 and x plus 2. If we multiply these back together using FOIL, we would end up with x squared plus 4x plus 4. And that equals 25. Now let me show you why this is a handy strategy when you have a perfect square binomial. We can write it x plus 2, quantity squared, equals 25. Now the x is in the parentheses. This whole quantity is being squared. So we can take the square root of both sides. And now this basically cancels this. So we have x plus 2. Over here, we have the square root of 25, so we write plus or minus 5. So we need to get x by itself, so we will subtract 2. So x is equal to minus 2 plus or minus 5. Here's another one. Again, we want to recognize that this is a perfect square trinomial. And we can write x minus 7 times x minus 7 as x minus 7 quantity squared. And we can now take the square root of both sides. So we have x minus 7 equals plus or minus 5. And then we add 7 to both sides. So x is equal to 7 plus or minus 5. I'm going to go back a second here. I forgot to finish something on this last problem, so I'm just moving back. Sorry about that. But our solution here is minus 2 plus 5 and minus 2 minus 5. So there are two answers. X squared typically will give us two answers. So minus 2 plus 5 and minus 2 minus 5. So we have to solve both of those. So it would be 3 and negative 7. So Sorry about that. Now going back to the problem we were on, when I got to this point, I realized I'd forgotten it last time. So this would be 7 plus 5 and 7 minus 5, which is 12 and 2. Those are the two answers that we end up with. And we will do one more. We'll pick the one with a fraction here. If we have a perfect square trinomial, so that will factor. So we have x plus 4, quantity squared, equals 16 over 9. And we'll take the square root of both sides. So then that would be x plus 4 equals plus or minus. And this is the same as taking the square root of 16 and the square root of 9. So that would be 4/3. And now we subtract 4 from both sides. So x equals, let's see, if we have minus 4 plus 4/3. That would be negative 2 2/3. And if we have minus 4 minus 4/3, that would be negative 5 1/3. Now notice this strategy that we're doing only works when this is a perfect square trinomial. And so we're going to use that idea to solve problems that aren't perfect square trinomials. Now let's look at a perfect square trinomial for a minute. Let's look at the relationship between the numbers. So notice this middle term. If you take half of that, you'd get 5. And to get this term, you would square 5. So that's the strategy we're going to use to form perfect square trinomials. We're going to take your b term, which is this. Remember, you have an a, a b, and a c. We're going to take b and divide it by 2 and square it. So here, x squared plus 18x, if we wanted to form a perfect square trinomial, we would take the 18 right here, divide it by 2, which gives you 9, and then you would square it. And so we would add 81. Now, this could be factored into x plus 9, x plus 9. We have a perfect square trinomial. The next example, we would take the 20, divide it by 2, that's 10, and square it. 10 squared is 100. Here's another example. Negative 1 is the middle term. Now you take negative 1, divide it by 2, that's negative 1/2. And you have to square that, so that would be 1/4. If we were to factor that, that would be x times x, and negative 1/2 times negative 1/2, that would make a positive 1/4 here. And if you multiply it back together, the outer and the inner term would give you the negative 1x. In this example, take 24, divide it by 2, you get 12, square it, it would be 144. And that would factor into x minus 12 times x minus 12. So there's some practice with those. So let's talk about how we would solve a problem. You'll notice we have a trinomial here. There happens to be 0 on this side. How would we solve one of these when it's not a perfect square trinomial? Well, the steps for completing the square are as follows. Step 1, we want the a value to be 1. So if there's a number that is greater than 1 or that's not 1, divide every term by that number. So that gives us x squared minus 4x plus 2 equals 0. The next thing you want to do is bring your c term to the other side. So if I subtract 2 from both sides, we have a negative 2 here. Now I like to leave a space here and here when I do this. So we want to have a perfect square trinomial right here. And here's how we're able to do this. What we do is we're going to take the middle term, divide it by 2, which would be a negative 2, and then we're going to square that. That would be 4. So we want to add 4 here to make a perfect square trinomial, but because we have an equality, if we add 4 to this side, we have to add 4 to this side. Now we can factor the left side. So that would be x minus 2 quantity squared equals 2. And then we will solve like we were doing before. So we have x minus 2 equals plus or minus the square root of 2. And then we'll add 2 to both. So x equals 2 plus or minus the square root of 2. That's your answer. And as you can see, if you plug 2 plus the square root of 2 and 2 minus the square root of 2 into your calculator, you would get 0.586 and 3.4. And those, if you graphed it, would be your x-intercept. So that's what x is equal to when y is 0. All right, let's do another one. Solve by completing the square. So the a term is 1, so we're able to go ahead and just move your c term to the other side. So we have x squared minus 12x equals negative 7. I'll leave some space here for that term that we're going to put in. So we'll take negative 12, divide it by 2, which would be a negative 6, and then square it, so that would be 36. So when we factor, we have x minus 6 equals 29. So we have x minus 6 quantity squared equals 29. And we take the square root of both sides. So we have x minus 6 equals plus or minus the square root of 29. So x equals 6 plus or minus the square root of 29. And like in a problem like this, the first thing we want to do is bring the 10x to the other side. So here it's a plus 10x, so we'd have to subtract 10x. And then we can move the c term over, because we want the x squared and the x term on the left, or on the same side, I should say. And from here, we can find the term that will give us a perfect square trinomial. So 10 divided by 2 is 5. 5 squared is 25. So now we have x minus 5, and that would be x minus 5 equals 13. Take the square root of both sides. So that would be plus or minus the square root of 13, and then bring 5 over. So x equals 5 plus or minus the square root of 13. All right, one last problem here. This problem, we have a 4 in front. So we're going to divide every term by 4 so that our a value is 1. And 10 over 4 is the same as 5 halves x. 0 divided by 4 is 0. So we'll bring 3/4 to the other side. Now, we have to take this middle term and divide it by 2. So 5 halves divided by 2. If you will recall, when we have fractions, when we divide fractions, we actually multiply by the reciprocal. So the reciprocal of 2 is 1 over 2. So that would be 5/4. So that is dividing it by 2, but then, remember, we also have to square it. So that would be 25 over 16. So that's what we're adding to both sides. So this is a little bit messier. Now we'll go ahead and factor. I'll write those both out this time. So that would be x plus 5/4 and x plus 5/4. And here we need to get a common denominator. So if you add 3/4 plus 25/16, that would be 37 over 16. So now we have x plus 5/4 quantity squared equals 37 over 16. Remember, when you're adding fractions, folks, that you need to get a common denominator. If you're using a calculator that has a fraction key, you can also just plug that in, 3/4 plus 25/16. So we'll take the square root, will be plus or minus. And now when we take the square root of 37, that's 37. When we take the square root of 16, that's just a plain 4. So lastly, we need to subtract 5/4 from both sides. So x equals negative 5/4 plus or minus the square root of 37 over 4. All right, that should give you a good idea about how to complete the square. Let me know if you have questions. Thanks for watching.